Composite functions. Given f of x equals 1/3 x squared and g of x equals 3 over the quantity x plus 1, find a. f of g and b. g of f. So starting with part A. f of g, usually written like this to say of x, can also be written as f of g of x, like this. This is an easier way to see it because we see that g, the function g, is being plugged into the function f. So we start by looking at the function f. Here it is. And in place of the x, we put the function g. So I put 1/3 instead of the x. I usually leave a blank and then say squared. In place of the x, I'm putting the g function, which is 3 over x plus 1. And now we simplify. So to simplify, I'm going to square this first. 1/3 is still out in front. 3 squared is 9 over quantity x plus 1 squared. I'm not going to take the time to FOIL that. It's generally not going to be useful to do that. 9 can be divided by 3 times, and I have 3 over the quantity x plus 1 squared. Let's look at part B. G of f, and usually written with an x to say with respect to x, or of the function with x. Let's rewrite that as g of f of x. That means I'm taking the function g and I'm plugging into it what f of x is. So wherever there is an x in the g function, I'm going to leave that out and put parentheses there instead, plus 1. In place of where that x was, that I left a blank for, I'm putting in that f function, the 1/3 x squared. And now I can simplify. 3 is still on top. 1/3 x squared doesn't really need parentheses, plus 1. Now this is a complex fraction, meaning a fraction inside a bigger fraction. I don't want that. So how am I going to get rid of that? I'm going to multiply. That's the opposite of dividing, and this is what I'm doing here. I'm dividing by 3. So down here, I'm going to multiply by 3, but I have to balance that in the fraction by also multiplying in the numerator by 3. So distributing down here by 3, the numerator says 9. The denominator will say x squared plus 3. And there we go.